Now let's take a look at this figure 22-6 that deals with the general lighting loads, and it's column 1, demand load 1 that we looked in the illustration previously. And notice the general lighting load is the 3 VA per square foot in 220.14J, and then we can apply demand factor in accordance with table 220.42. Now the general lighting load, we can put receptacles on it, cord and plug connect appliances. We can cord and plug connect the items that are listed there. And then we could have lights also on this general purpose. So we have our receptacles, and then we have our small appliance circuits of 220.52A and B, and the demand factors again can be applied in accordance with table 220.42. So let's look at the calculation. What is the demand load for the general lighting load of a 3,500 square foot dwelling unit? Step 1, we go to 220.11 and 220.14J. We pick up 3 VA per square foot, and we come up with 10,500 VA. Step 2, we need 3 small appliance circuits. 1 for the kitchen, pantry, dining room, and breakfast room. 2 there, excuse me. And then 1 for the laundry room. So that'd give us 3, so 3 times 1,500 is 4,500. Now let me call out one thing about step 2. Some inspectors would require you to add in a 1,500 VA for the 20 amp required in the garage too. You have to pull a 20 amp there. You have to pull a 20 amp to the bathroom. But there's not anywhere in your 210.52 A and B, as well as your 210.11C, that requires 1,500 VA for those circuits. It's just these 3 that the code requires 1,500 VA, or allows you just to use 1,500 VA in accordance with 220.52 A and B. So keep that in mind. Talk to the authority having jurisdiction if you feel like there's a problem. Now, step 3, we take the general lighting load calculated in step 1 at 10,500. The small appliance circuit in step 2, 4,500. We get a total of 15,000 VA. Now we can apply the application of a demand factor in accordance with table 220.42. We take the first 3,000 at 100%, 3,000 from 12,000 now at 35% would give 4,200, a total of 7,200 VA. So the demand load, when calculated, comes up to 7,200 VA. So you can see when you take the first 3,000 at 100%, that is subtracted from the 15,000. That's where your 12,000 came from in step 4. So when we do our math in step 1, 2, and 3, as well as 4, we come up with a solution of 7,200 volt amps. And you can see that's quite a reduction from 15,000 if you didn't have the demand. That's quite a reduction in load there. So this is one of the demands that could be applied. And notice one thing. A demand is always less than 1. It's less than 100%. But diversity is over 1. It's over 100%, like 1.5, 2.5, and that kind of thing. But you have to go to the Electrical Engineering Handbook that McGraw-Hill puts out to obtain diversity. And then you have to get permission from the authority having jurisdiction to use a diversity, like on a feeder or something going up to a total electric facility. So kind of keep that in mind. The demands you're looking here are strictly for dwelling units only, and that's what this figure 22-6 is illustrating to the user of the NEC.